Good morning, I'm Cindy and this is my training briefing. So what our team working on is fingerprint recognition. So this term is definitely not something new to all of you here, but I guess not many of you actually understand what kind of process this device is actually undergoing. So today we are here to introduce you the working mechanism of this technology, and however there is some inherent problem. However, there is some inherent problem under the current technique, so we will look at this problem and to see if there is any advanced technology to solve them. And finally, we will finish by doing a comparison with the advanced technology to see if it can truly replace the existing one. So to start off, we will fingerprint recognition is actually the most widely used biometric device for personal identifications. The main reason is that the first one is everyone has a unique fingerprint. Even twins, they will not share the same fingerprint, and so it will enable us to distinguish one person from the other persons. And secondly is that it is permanent, so that means it will remain unchanged during our lifetime. And more importantly is that the patterns in our prints is actually have some general characteristics. So that means we can do a systematic classifications, and actually we can actually describe our fingerprint. So for that, so it has been used for many years, and forensic science has first adopted this technology for tracing criminal, but nowadays much more applications are actually used for authentications, such as the e-channel. So whenever you press your finger over the C2 scanner on the e-channel, so have you ever wondered what kind of process this scanner is actually doing? So my teammate is going to explain to you the working mechanism of this technology. In terms of the technology, there are three stages of the fingerprint recognition process. There are image acquisition, processing, and matching. For image acquisition, we can use optical sensors are the most widely used device to collect fingerprint nowadays, and we can see the optical sensor as a computer with a glass platen. So when we roll our fingerprints on the glass platen, the scanner will actually electronically send the image to the database or system. So after getting the image, the system has to perform pre-processing and extract the features of the fingerprints. And in general, there are 6 steps at this stage. They are segmentation, enhancement, binarization, thinning, financial marking, and post-processing. So firstly, we have to perform segmentation to distinguish between the foreground and the background, and to identify the noisy area around the borders of the fingerprints. And according to 3 experts, our fingerprints can be segmented based on its variance. And we understand that the foreground is the area with the most variance, while the background has no variance at all. So by dividing the image into square blocks with size 16 times 16 pixels, we can calculate the correlation between the foreground and the background, so to isolate the foreground. And after that, we have to normalize the values of the image in order to enhance the contrast of the image for easier processing later on. As we can see, in the fingerprints, the valleys and the ridges vary slowly, so we can apply a bandpass filter that tunes to the corresponding frequency and orientation to remove the noise and sharpen the lines. And the first step is binarization. It is a process that turns a 8-bit grayscale image to 1-bit binary image. And if the pixel values of grayness is greater than the values in the orthogonal direction, that pixel would be a black region. That means it is say 0 in value. Then after that, we have to thin the image in order to eliminate the redundant pixels, so that all the ridges and the values will be at 1 pixel thick in the end. And the final and the most important step here is financial marking. From a computer science point of view, how do we compare a fingerprint image to other fingerprints? We can't just simply do a bit pattern matching matching because obviously each of these images is different. So what engineers do is to extract something called minutiae. Actually, minutiae means the features of the fingerprint. And after getting the minutiae, so I would like to introduce something called crossing number. And crossing number is widely used in minutiae marking. So by definition, crossing number is the half sum of the differences between a pair of adjacent pixels in an egg-connected neighborhood. So what does it mean? Let's look at this 3x3 window. So we can see that there are 8 neighbors surrounding the central pixels. So the differences, take the first case as an example, we can calculate the total sum of difference will be 1 minus 0 plus 1 minus 0 and so on. So we get the total sum of difference x. Then x is divided by 2, then the crossing number will be 4. Then we understand that if the crossing number is 4, that means there is no neighbors surrounding the central pixel. Then we understand that it is an isolated point. For another example, if the crossing number is 3.5, that means that there is one pixel surrounding the central pixel, then it is an ending point. And by this applying this knowledge, we can also map the rigid, verification, and crossing. And for the purpose of comparison, only ending and verification points are called minutiae points. And we come to the final step of this stage, that is post-processing. Its purpose is to eliminate the false minutiae. For example, if the ridge breaks due to insufficient ink, that ridge should become one single line again. And for example, where the rigid there is an overlap, then we should remove that minutiae. After the successful extraction of the minutiae points, we can compare this set of minutiae points to another fingerprint in the database. And actually, there are different algorithms can be used in matching the fingerprints. And here we use simple relapse match algorithms. That means for any pair of minutiae, if their length is short enough in a box and their direction has large consistency, they are matched. And if the match ratio is high enough, then 2 fingerprints come from the same finger. Now we are more familiar with the basic ideas of the fingerprint recognition process, but we can understand that if the image we acquired at the first place is very bad, it is no way for us to improve or heal the image, even if we have super brilliant algorithms. So to achieve an effective, better representation, so we have to acquire an image better at the first place, and Cindy will talk more about it.
So one thing that we did not specifically mention before is how the image is acquired. So for the traditional one, that means the one we usually use, we will press our finger over a rigid surface, and because of this act, some inherent problem arise. So the different contact pressure or different skin condition, like we will solve different representation of the same fingerprints. So for example, as you can see from the picture here, there are some distortion because of different skin conditions. So with the 3D touchless technologies, now we don't need any contact between the fingers or any rigid surface. So we could able to obtain a consistent image every time. But how does this work? So the underlying principle is that there is the remote sensing technology. So the first, the light will illuminate the finger surface, and the skin of the fingers will absorb a portion of the light, and the rest will be reflected back to the detector. So different thickness of the skin will absorb different amount of light. So the amount of light that absorbed by the valleys is different from the amount of light that absorbed by the ridges. So it could create a sufficient contrast and allow us to distinguish between the valleys and the ridges. So end up we can extract some important feature from the fingerprint for matching. And of course, we are not just use one camera or one detector. Instead, we are using the multi-vision system to capture more areas. So 5 cameras actually capture the image at the same time, and then we will able to obtain 5 views of the same fingerprint, and then we will combine them together to form a 3D image, which is the relatively like comprehensive representation of the fingerprint. But so far we don't have any database for the 3D image, so that means we cannot directly use the 3D image for matching. So we have to convert it back to the 2D image. But the resulted 2D image is with much higher accuracy and also is much more consistent now. So finally, despite that the touchless technology is really can give us a representation with a very high accuracy, but what we can observe now is that it is not yet a widespread choice, because and it is so far cannot replace the existing one. And the main reason is because the extremely high cost of the 3D touchless device. So compared to 3D, the 2D one is more cost effective, but it is expected that because along with the development of much more advanced technology which are currently undergoing, so we could expect that the 3D touchless technology will definitely become a widespread choice in the future. So thank you for listening.